Hey everyone, welcome back. In this video we're going to be continuing our discussion about the Arduino RC car. In the previous video we were talking about the project introduction, the objectives, and the overarching goals for this entire project. We also went into some details about the overall design I have for version 1.0, the chassis I'm using, the motors, the Arduinos, the motor shields I'm going to be using, and especially the RF modules I'll be using to communicate with this RC car wirelessly. In this video, we're going to be talking about more of the programming side of things, give you some details on how the transmitting works, how the receiving works, and I'll also give you a live demonstration on the RC car and how I'm able to control it wirelessly using that prototype controller I was building with the joystick. So let's jump right into the coding aspect of things. What you're looking at now is the transmitting Arduino code that's programmed into the controller I built that I showed you in the last video, which is this cardboard piece with the joystick, and it has the Arduino Nano on the back right there, and also the transmitting RF module. So basically what this controller is doing is transmitting the joystick data, the X and Y data, and I'll get to more details on how what that joystick data looks like. But let's just jump right into how I'm transmitting that data first off. So we'll start off with the libraries I'm going to be using. So the NRF has to be in there if we're going to use the RF modules. You also have the SPI, which is the serial peripheral interface, similar to I2C. That's kind of a master-slave type of deal. Some of the port declarations is CE and CSN, so I pinned those at 7 and 8, but you can use any digital pin for that. I was aware that some of these RF modules that you can buy elsewhere, some of the pins are in different orders, so I would make sure and look at the data sheet for your particular RF module and make sure you're correctly putting in the pins. One of the most important lines of this code is the byte address. So this address is the channel on which these two RF modules are going to be communicating on. So they need to be the same for the transmitting and receiving side so they can stay on that particular channel. To make it easy for myself, I just put 00001. It's a really easy byte address. I'm going to make sure that they're the same on both sides. We also have this joystick array that I built. So this array will be storing the X and Y access data from the joystick. Moving on to some more of the radio setup. So we have radio.begin to actually start the communications between the two RF modules. We have open writing pipe in this case. So since this is the transmitting module, we're going to be writing data and transmitting it to the receiving data. So in this case, we're going to be opening a writing pipe to this address. Set PA level. This really talks about the power level of the RF module, so you can set it to minimum or maximum depending on the range that you're going to be testing it on. I set it to maximum even though the demo I'm going to show you is still within maybe like a few feet of each other. In a future video, we really want to test the long range aspects of this RF module. The data sheet says it should be around 100-meter range, so I really want to give that a try. And the last part of this is the radio.stop listening. So there's two options. There's stop listening and start listening. Stop listening makes it so that this RF module behaves as a transmitter. And start listening would be, receiving that data, listening to the data being received through that address bus or that channel, which is 0001. Heading down to the loop, so the way the joystick works is the y-axis has its own port and the x-axis has its own port, and they both need to go to an analog read pin. So what I have set up here is that the first index in joystick reads the x-axis data and being read by A6, and the first index of joystick is reading the y-axis data, which is going through A7. And since it's a single array with the two pieces of information, I'm able to write that data onto the channel or the address bus into a single variable, which is joystick. So I'm able to get two pieces of data stored into one array and sending that one array to the receiving side. So let's jump right into the receiving side. It's a little bit more complex, but we'll go through one by one. Same library, so SPI and NRF. And some new things are the motor shields library. So you need since it's a new motor shield, the L293D, they have its own libraries to control the motor. So you need to put in AF motor and also servo. And we also have the servo libraries right here. So we need to initialize our servo, initialize our motor. So since I'm only using two motors, it's a rear wheel drive. If you need to add 3 and 4, you can also add those as well. And you need to determine the speed. Similar to the transmitting side, we have the CE and CSN ports, so 35, 34 for this case. And the byte address is also the same, needs to be the same for both sides, 00001. We're still initializing these data points that we're going to be using later on. Some new things, you need to set the speed of the motor. So as I said, the speed is 200 out of a range of 0 to 255. And attaching attaching the servo to pin 10. So pin 10 is regards to the motor shield itself. According to the datasheet, there's pin 10 and pin 20 for the two servo ports. And similar to the transmitting side, we have to declare that the radio is to begin. So we're starting the RF module communication. Since this is receiving data, we're going to be doing open reading pipe, so it's going to be reading data on that byte channel. Setting the PA level to max just for long range use. And in this case, we're going to be doing start listening, like I mentioned. So this is going to be listening for data coming in from the transmitting side. Heading more into the loop itself, we have the radio dot available, so we want to make sure that the radio is available at the time. If not, we're just going to break the loop. And instead of radio.write, now we're going to be reading data, so we're going to use radio.read, reading the joystick array that's being transmitted, and I'm storing the x-axis data in x, which is the first index in here, and similar for that for y. And this is a mapping feature, and I'll get into that in a second. As you can see, it's still being beta tested. And some of the conditional statements. So this is kind of where all the movements of the RC cars really starts. So like I mentioned in the previous video, and it's also on my GitHub, the joystick works in a coordinate system. And how that works is from left to right for the x-axis, it's 0 to 1023 analog to digital data. From up and down is also 0 to 1023. So really at a neutral position, it's around like 500 to 530 that incoming data is what it's looking like. So 500 to 530 is really in the neutral area. And if you want to go forward, if you want to go up, you need to go past that threshold or below that threshold depending on which direction you want to go. So in this case of being forward, we want to be less than 495 to make sure that the RC car is going to be moving forward. In the backwards case, it needs to be greater than 530 up until 1023 to be moving backwards. So these kind of thresholds need to be set so that you know that the joystick is going to be going forward or backward, and communicate to the RC card that it needs to move forward and move backward, and telling the motors to run backwards or forward accordingly. Same thing with the left and right condition. As you can see, these thresholds are really low, and that's because I'm still testing the mapping feature. So what the RC car is doing now is when I turn left, it turns all the way to the left. So 0 degrees or 180 degrees for the servo motor. And what I really want to do is really be accurately determining how much to turn. You know, you don't want to turn all the way all the time. You want to kind of feel out the joystick. If you want to turn this much, you can just move the joystick just a little bit to the left, or if you want to turn hard right, you could turn all the way to the right. So I really want to have accurate steering so that it behaves just like a normal car. So I'm still working on that, and that's how the mapping feature will be utilized. So in a future video, I'll discuss how far I get with this beta program. And like I mentioned, in the neutral position, when the joystick is not being moved, I want the motors to be still, and the servos need to be facing forward, so it's the RC car is facing forward. So that's it for the programming side of things. I'll jump into the live demo just right now and show you how responsive this program is and how I'm using the joystick and the controller I've been prototyping with the cardboard piece. So let's hop there. Alright, so here's the live demonstration of the Arduino RC car, the version 1.0 I have right now. So as you can see on the larger screen, we have the Arduino RC car on the bottom left on the floor. And in the picture-in-picture window, on the right side, we have the transmitting controller right here that I built with the cardboard box I showed you previously, with the Arduino Nano on top, on the back, and the RF module on top. And we have the joystick right here. So we turned it on. I have an on switch for the battery pack, so the light is on, so we're ready to go. And let's just jump right into it. So here's the forward. There's backwards. As you can see, it's really responsive. We also have the left rotation, or the right rotation, sorry. You can also go backwards. So that's the right side. You can go backwards, go left a little bit, go backwards. As you can see, the distance is small. I'm about a few feet away from it. Apparently they have a 100-meter range, like I said. But I think that even at a long range, this will be very responsive. So, just how responsive it is to just the slightest amount of touch is pretty signifying how well this is communicating over that channel. It's very responsive, even at up close, and I'm sure that long range will be the same as well. Maybe a little bit of lag, but nothing too dramatic. So, yeah, so that's the live demonstration. As you can see, it's very responsive. And hopefully in the future, as I add more features to it, I can add more functionality to this controller, like the auto button and maybe a camera button here, so I can swivel around the camera on the top of it. But that's it for this part of the video. Thank you for sticking in with the live demonstration. In future videos, I'll update you on anything I add as a feature, maybe buzzers. I was planning to add either active or a passive buzzer to play some songs, and hopefully I can work on that long range test as well. So thank you for watching, and I'll see you guys next time.